In Part 5, we will discuss directories and devices. Like Windows, Unix and Linux have a hierarchical or tree-like directory structure. The top level of this is simply slash, the main directory. For the record, Unix was one of the first systems with a hierarchical directory structure, and a lot of the way it's organized in Windows, to a certain extent, was taken from Unix. Now you'll notice here I type ls space slash, and you can see a variety of different files. Bin, those are executable file or binary files. Dev for devices. You can see media for different things there. We'll talk about a few of these as we go on. These are some interesting directories that we have under the main directory that are actually viewable to one extent or another by the various users on the system. Slash is the root directory for the entire system. Under that, virtually all systems will have a directory called slash bin for essential programs in binary or in which is also known as executable form. Slash dev is for devices. Unix views devices as files on the system. How it does this is something we'll take a brief look at a little later. Slash etc or etc is for administrative files or miscellaneous files along the way. This will include the password file slash etc slash password, which is not always visible on most systems. It'll also include slash etc slash MOTD. MOTD stands for message of the day, as we've seen before. Slash lib is where essential libraries are stored, largely for compilers and other programs like that. Slash tmp for temporary files. And the kernel, or the main portion of the operating system, is stored in the slash Unix directory. USR is intended for files that users are more likely to use. USR ADM is for the sysadmin or system administrator and many of the utilities that someone needs if they are running or maintaining a Linux system. USR bin is for binary files of users may make use of. USR games, something that may not be as common on newer systems, but was quite common on Unix systems many years ago. Slash USR include the header files that you use in C programs. Slash USR slash man, the online manual. Slash USR slash SRC, the source code for many of the utilities. USR slash spool for files that are being saved that are waiting for their opportunity to be outputted. Slash USR slash spool slash mail, directories for mail that is both coming in and going out. As I mentioned before, the system to a large extent treats devices like it would any other file. That means there have to be directory entries for them. Peripheral devices will have file names such as slash dev slash mt0 or slash dev slash tty01 and may be used in the manner of other files on many systems. You can write cp slash dev slash mt01 junk because a file is considered just a pattern of bits. What you see here is a listing for the device directory slash dev, and you'll see ellipses in several places where I deleted various entries. There are just so many of them, and at a certain point it's just more and more of the same. The first line you'll see is CRW and then a whole bunch of dashes. C tells you that it is a character-oriented device. In other words, like a keyboard, like a monitor, or something like that. Immediately below that, you see a link. Links are indicated by an L, as opposed to a regular file which would simply have a dash. Immediately below the ellipsis, you'll see one that begins BRW-R and a whole bunch of dashes. That's a block-oriented device. In other words, a disk drive of some sort. The rest of them are essentially more and more of the same. In addition to calling your attention to the fact that the owner in every instance is root, which is a name for the person running the system management in general. You see the group in many cases is root, or in some cases floppy. You'll see a set of pair of numbers separated by a comma in some places. These are the major and minor numbers. We'll be talking about them differently. The 36, 8. The 8 does not refer to the number of bytes. It's not part of the date. What it is referring to is the minor number. We mentioned major and minor device codes before. These two numbers mean somewhat different things. The major device code indicates the type of device it is and gives a clear indication of which device driver or machine-specific procedures it needs the operating system to use to manipulate it or make use of it. The minor device code is identifying a particular device of that type to distinguish it from other devices of that type. One thing that you'll notice that makes a Linux system very different from something on Windows is that you see no mention anywhere along the way of which disk drive or which device has which file on it. The reason is that the system makes use of a process called mounting. We'll talk about that a little in a moment, but let me explain why we need this. The main system has a main directory /, and under this it has directories /bin, /etc, /usr, and others along the way. Now, a Unix system can be made up of separate file systems. These separate file systems may be on different partitions of the same hard drive, or even different hard drives. Now, you'll notice here, in the case of USR, that we have a separate file system /dev/dk01. This device has 3 directories under it: local, Joe, and Mary. Local has 2 subdirectories of its own, and so on. What the mounting process means is that we have an association between /usr and /dev/dk01. They are one and the same. So when we are looking for subdirectories of USR, these will be local, Joe, and Mary. Now, we can unmount and we can mount it onto something else if we wish to. The advantage of all of this is that we have the appearance of one operating system that seems to be seamless, even though it is made up of many different parts. Chown and Chegrup, if you can pronounce it that way, allow you to change the owner of the file and the group to which the file belongs. Chown does allow you to change the owner of the file. However, in Linux systems, this is only allowed by a super user, or root, or more accurately, someone with system administration privileges. Chgroup allows you to change the group to which the file belongs. File lets the user search through a list of directories for a file that meets certain criteria. On the next slide, we'll see exactly what we'll use this for. The general form is find, the directory in question, and what the criteria are. -inum allows us to look for a file with a particular inode number. -links will look for a certain number of links. -name and then pattern will look for a name that matches the pattern we're looking for. -newer file looks for a file that's newer than the one in question. And -user lets us look for a file owned by the name that we indicate here. Here you'll see we write find name alloc, and you'll notice that we can find here the file alloc in my C directory. Find -user Siegfried, and we can find all of the directories with files that I own. ls-I, and I can now look and find the file 411, the file CSC 390-7Z, and so on. I type find-inum 6488148, and I find the file with the name 411. Where is will search for a command and will list where its executable file or its source code file is located, or where its online manual page is located. And it'll search in the standard places that one would expect Linux to have placed these files. What it'll give you is the absolute path, all the paths in the directories and subdirectories starting from the root directory of the system for the binary source or manual pages with the names given as command parameters. There are three options I have here. -B will search for binary or executable files, -M for manual, -S for source code. Here we have some examples. Whereas FTP shows you the locations of the executable versions of FTP as well as its manual page. The -B for FTP will only list where the executable files are. I can do this for cat, and I can find the binary version of it and the manual page. Where is space -S cat types nothing, because on the system I don't have the source code listed. Where is -M will give me the location of its manual page. I can do this for both ls and ln, and in both cases I'll get the listing of the executable and manual pages. Which is a little bit like where is, but what it'll do is return the path of the commands that appear on the command line. So for example, the files that appear are in the current path of the user. So which cat will show me where the executable file is located. For cat, as you see here, for ls, for F77 as well.